today we're going to start talking about characteristics of linear functions. Okay, we have quite a lot of notes to fill in. A lot of times, the complaints that I get from your parents or people of your parents' age, no disrespect intended, is that I don't give you a book. Okay, well, first of all, that's not true. You all have books checked out to you, right? But the worksheets don't go along with the book. I can't say, if you want to go look in the book on page 304, this is what we're talking about. I don't know where it is in the book. I'd have to look for it. Okay? Which is what they would have to do. So what I'm trying to do here is I'm trying to get you some notes that go along with what we're talking about. So if you are working on this at home tonight and you're struggling and your mom's trying to help you or your dad's trying to help you, which is awesome, they have something to look back to as well. Okay? So let's fill in a bunch of notes today. All right? What is the linear parent function? Y equals x. Okay? What is the domain of the linear parent function? All real numbers. That's one way to write it. What's the other way to write it? Negative infinity to positive infinity. I'm so sorry about that infinity sign. That's not pretty. What's the range of the linear parent function? All real numbers. What's the other way to write it? That's a little better, but I don't know why mine are so messy today. You'll just have to get over it. What's it look like on a graph? A line. Okay, we can start with that. A line. When x is 1, y has to be 1. When x is 2, y has to be 2. When x is 3, y has to be 3. Why again? Why does it have to be? Because y equals x. Okay? Now I'm going to put the dots all the way to the edge of the paper so I can see exactly where the line goes. I would recommend you do the same so we're not guessing. Okay? It's a good question, and I'm sorry I started drawing the line before I answered your question. Do we just draw the dots, or can we draw the line? What were we given first? An equation. So yes, we can draw the line. Okay? So what's my table look like? So negative 3, negative 2, negative 1, 0, 1, 2, 3. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Thank you. What pattern do you observe in the table and the graph of the linear parent function? Okay, that's good. All the x's equal the y's. Is that good? Sharpen it? Oh, you're fine. You're fine. Go ahead. Go ahead. So let's talk about their characteristics. Okay? You've seen all of these, but do you remember any of them? If you don't, that's okay. That's why we're talking about them. I'm not just assuming you're remembering them. Hopefully you know this one.
Yes.
Slope-intercept form. Y equals mx plus b. You know what this crazy kid said earlier? He said f of x equals mx plus b. Is that okay?
Yes.
As long as you know that f of x equals y. As long as you, and it's a line. Are all lines functions? Every single line, is it a function? No. What about like vertical lines? Are they functions? No. Okay. So we have to be careful using this. We have to know it's a function before we can start writing that, don't we? Okay. What about standard form? Do you know standard form? AX plus BY equals C. Okay? A little note that I need you to know about in here is I need you to know that there are A and B and C are not fractions. And I need you to know that A is positive. point slope form? Anybody know point slope form? How about if I tell you? Y minus y sub 1 equals m times x minus x sub 1. Now, I heard some noises when I was writing that down. Normally the noises you make when I say this is, oh, I remember that. Is that correct?
I remember that.
Oh, good. I'm glad you remember that. Okay. In slope-intercept form, explain how changes in m and b affect the graph of the parent function. You should have absolutely no problem filling this in right now because it was on the video, right? Fill it in real quick, please. It works on every phone that I've tried so far this morning. I'm sorry, I can't do anything about that. That's why we do it at home. Tell me one thing you put here.
Changes the slope.
Changes caused by m. Can we say something different than m changes the slope? Be a little more specific.
Steepness or shallow.
Steepness or shallowness. Is that even a word? It is now.
I just love steepness.
Okay. What about if m is less than 0? Decreasing line, right? What if m is greater than 0?
Increasing line.
What if m equals 0? Once upon a time, my friend... Whoops.
Jill.
Ignore that. What? Jill? I have a friend named Jill. Okay. My friend Jill went skiing. See what she's doing right now?
She's going up the mountain.
Can you see her? Whoops, wrong way. Can you see her? She has a little toboggan on, right, so she can't see her hair so much. Or her hair could look like it's on fire, either one. But she's excited, right? She's super happy for this day. She rides all the way up the ski lift. What do you guys know about skiing? Anything?
You do it in snow or water.
You do it in snow? Okay, excellent. Jill accidentally got off on a black diamond.
Oh
She didn't drop
no. A few more.
She made it down. Except, whoops, her skis fell off. Hold on. Except then, she got right in this really super flat part. And she wasn't going anywhere. And then, this giant gust of wind came and blew her off the side of the mountain. And she died.
I like this story.
Oh my god! Oh, she's dead.
Okay? So let's talk about why we just talked about my friend Jill. Okay? Look at this side of the mountain. This side of the mountain is increasing. What was her attitude that day?
Increasing.
She's excited.
She was super positive. Ah. And then she got off on the black diamond, and she was Decreasing and very negative. And then, when she got to the bottom, what's her slope here? 0. There's no movement at all right there, is there? So horizontal lines have a 0 slope. Okay? And vertical lines, what? Tell me about Jill right now. She is undefined. Okay? Yeah, see how her arms are even unattached. She even came apart. Okay? So for those of you that are visual learners, does that help at all?
Yes.
Okay, so then let's go back here. What does m equals 0 mean? Horizontal line. And when m is undefined, okay? Any questions? So tell me about changes caused by B. B affects the Y-intercept, okay? So affects the Y-intercept. How do I know it's A here instead of E? It also says in the directions. Yeah, it is not a reaction, but you're right, it also says in the directions. Okay? It affects the Y-intercept. So how? Let's start here. If B is 0, crosses, intersects, is that what you said? I'm sorry, I already started to spell crosses. That's right. Crosses at the origin. What if B is greater than 0? Let's use some of our transformational words. Can we do that? So if B is greater than 0, what? Vertical shift. Okay, I know you weren't here at the beginning of the year when we talked about this, but what I need you to remember is that F's are very important in this word. Okay? Please don't forget your F, because if you do, it's a totally different word. Okay? It's a vertical shift where? Up. And if B is less than 0, if B is negative, vertical shift down. Any questions about that? Now, that was pretty quick and painless because it was in the video, right? Okay? So, how would you define slope? Let's talk specifically about the M. For the record, there's about 8 or 12 things we could write on this line. 8 or 12. Maybe 9.
It's the horizontal movement, or the vertical movement over the horizontal movement.
Rise over run.
Okay, so rise over run. Let's start there. I think that's what you were trying to say, right? A little bit more succinctly, is rise over run. Okay, how else could we say this? How else could we define slope?
Steepness.
Change in Y over change in X. I just heard another one. Let me write it down. The steepness. Y2 minus Y1 over X2 minus X1. That's the actual slope formula. I'm okay with that. One more that's super important. We'll just go with 5 for today. Is that okay? Rate of change. Okay? So how do you find slope from each one of these representations? Well, if we have a graph, it says count. What does that mean? Rise over run. In this particular example, we rise 1, 2, 3, 4. We run 2, which means our slope is 2. What about in a table? Why is it 4? From here I count 1, 2, 3, 4, and then 1, 2.
I was sorry, I was coming from the wrong spot.
You're fine. What about from a table? How do we find it? So this is our change in y's over change in x's, right? Okay. What about 2 points? That's our formula, right? And what about our equation? Look. If it's in slope-intercept form like these first two, what am I looking for? Look for the x. There's my slope. There's my slope. Notice what I did not circle. What did I not circle? I did not circle the x. Okay? What if it's in standard form? Get it in slope-intercept, right? And then look for the x, right? Finding intercepts. What is an intercept? Where the line crosses an axis. Now, what I heard you say was where the line crosses the x-axis, right? I heard somebody say that. Except we're talking about an intercept. We're not talking about an x-intercept. We're not talking about y-intercept. We're just talking about an intercept. So we're not being specific about which axis we're talking about, right? Okay? So, tell me how to find a y-intercept if you have a graph. Where it crosses the y-axis. Pretty simple, right? What about from a table? If we're given a table, how do we find the y-intercept? 0, comma, something. What do we want to put in there?
Y.
A y, right? What if it's in slope-intercept form? Identify the b. What about from any equation? Plug in x equals 0 and solve for y. Look, you can tell that from the point in the table. Isn't x equal to 0 where the y-intercept is? Okay. Now, does it seem weird that we're finding a y-intercept and it's the x we make to 0? Some people have trouble with that. Are you okay with that? Okay. If you are good, if you have trouble with it, how are you going to remember it? Whichever one you're trying to find, it's the opposite, right? It's the opposite letter we let be 0. Maybe not opposite, because I can't really say x is opposite of y, but the other variable. How about that? Will that work? So how do we find an x-intercept? What about from a graph? Where we cross the x-axis? What point are we looking for in a table? X comma 0. And what about an equation? Plug in y equals 0 and solve for x. Any questions? Couple more things to fill in. To find an equation, actually, do I want to do this yet or do I want to wait till tomorrow? Yeah, but we better do it just in case. There are several ways to determine the equation of a line depending on the information given. What if you have the slope and the y-intercept? What should you plug your values into? In what, though? Slope-intercept form. I know that seems a little silly, but guess what? There's those crazy kids that don't remember that, so I'm reminding them today. If you have a slope and an intercept, put it in slope-intercept form. Okay? What if you have the slope and a point? Point slope form, right? Point slope form, which is y minus y1 equals m times x minus x1. What if you have coordinates of 2 points? Put it in slope form. Then, once you have the slope, then you have a slope and 2 points. Then, point slope form. Okay, wait, are these the only ways to do this? No, you guys know how I feel about that, right? There's almost never just one way to do stuff. These are probably the quickest and easiest for most times. Fair enough? Okay, so what if you have a table of data? Linear regression. We have not talked about that in here yet this year. We will soon. That's foreshadowing. Dun, dun, dun. Okay. Special lines and slopes. Special lines and slopes. Horizontal lines have what kind of slope?
0.
M equals 0. Sample equation. If it's y equals mx plus b and m is 0, what's the equation going to look like? Y equals 6. Why did I put 6? Because that's what I heard, right? Okay? That's a B for the record. What about a vertical line? Undefined. My dead friend Jill, right? So what's the sample equation here?
X equals
Yes, x equals 7. That was weird. What do you know about parallel lines and their slopes?
They're the same.
Slopes are the same. For example, y equals 2x plus 1, and y equals 2x plus 5, right? As long as the slopes are equal, we're good. Wait, could they both be negative 2? Wait, could they both be negative a half? Wait, could they both be positive a half?
Yes.
Yeah, as long as they are the same, right? Okay, perpendicular lines.
They're the opposite reciprocal.
Very good. Opposite. Reciprocal. For example, if I start with y equals 2x plus 1 again, what's an opposite reciprocal of 2? Negative 1/2 x plus what? 14. Wait, could it be this? Could it be plus 1? Could their y-intercepts be exactly the same? They could. We didn't write it that way, but they could. Okay? So these are the problems you're responsible for tonight. You ready? 1, 2, 3. Turn the page. 1, 2, 3. 1. This one. Let me zoom out just a little bit so you can see it a little bit better. 1 here. 2, 3. And then 1, 2, 3. Okay? You have the rest of the period to work on these. Does anybody have any questions before we work individually or work with our groups? How are you feeling about all this stuff? Good? All right. Peace.